let's talk about your term project. So we've spent the first unit exploring what science is and how science is done. We've looked at the scientific method, okay, which we can see here on this chart here. Okay. So when we do a study, we have a purpose. So we figure out, what are we trying to solve? What do we want to study? Sometimes we do some preliminary research, some information gathering before we put our hypothesis together. Then we put a hypothesis. If I do this, I think this will happen. Or if this occurs, I think this will occur. Okay. Then we do our experiment. So we're going to make a plan. How do we carry out the experiment? Then we actually do the experiment. Once the experiment is done, we analyze our data and then we form a conclusion. And we figure out, was our hypothesis correct? Yes or no? So you are supposed to identify something in your own life in order to do this project with. The first part of our term project has you identifying 3 potential projects that you could theoretically, conceivably carry out in your daily life. Make sure it is something that you can actually do. Don't come up with an idea and then realize, oh, wait, I can't afford to do that idea, or, ooh, I don't have access to those things in order to do that idea. I had a student one semester that really, really wanted to try an experiment dealing with using the same type of gas on multiple different cars to see how the gas mileage changed. He ran into 2 problems. 1, he didn't have access to enough types of cars. And 2, he realized that even if he did have access to the many types of cars, he didn't have enough money to put that much gas in all the cars. So as you're coming up with these ideas, make sure there's something that you can do. So I'm going to demo a little bit of an idea for you right now. All right, so as I have mentioned before, I'm a chemist. Okay, so usually I teach chemistry classes when I'm not teaching this class. So during COVID, I've had to teach a lot of chemistry from my garage using at-home lab kits or equipment that I borrowed from work in order to do demos over Zoom for my students. One of the things I borrowed from work was a bottle of silver nitrate and a bunch of copper wire. So in chemistry, there's these really cool types of reactions called single replacement reactions. I've mentioned them once before, where if you have something that's in solution and you have something that's not in solution, if one thing is more active than the other, they'll change places, okay? And silver and copper are 2 of those substances. Copper happens to be more active than silver is, or you can think of it as more reactive. So if I have solid copper, but I have silver dissolved in solution, copper actually wants to go into solution and silver wants to come out of solution. Okay, and it undergoes a reaction that looks like this. So I have my solid copper. I have my silver. In this case, it's a silver nitrate solution. Okay. And what ends up happening is I end up getting a copper 2 nitrate solution plus solid silver. In chemistry, we have to make sure everything balances, and that balances my equation right there. Okay, so silver nitrate starts off as a clear solution. Copper wire looks like this. Okay. When I put them together, I get this. I end up with a blue solution and a whole bunch of stuff coming out of solution. That stuff coming out of solution, I just knocked off the wire there, is silver. Okay, as the silver comes out of solution, it precipitates out on top of the copper wire, blocks the copper wire. So in order to keep the reaction going, I have to swirl it every once in a while. Now this copper wire that I got from work, it was coiled up in a box. And over the last few months, it got really tarnished. So what I did was I cut 5 pieces of copper wire, and I'm going to set up 5 containers with copper wire and silver nitrate to see if the amount of tarnish on the copper wire affects how fast that copper wire will dissolve into solution and have the silver precipitate back out. Okay, so in this experiment, I am testing the effect of that tarnish level on the rate it dissolves. Okay, So my independent variable is going to be my level of tarnish. Okay, my dependent variable is going to be rate of dissolving. Okay, because the rate of dissolving depends on the level of tarnish. Okay, I also need to have some controls. So what am I controlling in this particular experiment? Well, I am controlling the length of the wire. I am controlling the concentration of the silver nitrate, meaning it's going to have the exact same amount of silver in solution for every single container. I'm controlling the volume of silver nitrate. That also makes sure that I have the same amount of silver. So I'm going to pour out the exact same volume in each one. I am controlling the temperature. So all the cups are going to sit here in my garage at the same temperature. And I'm going to control how much I swirl them around. Okay, because once I break up all the stuff on the surface and I give access to the next amount of surface, the reaction can continue. So if I swirl one more than the other, then I give more surface area and that can affect it. So I'm going to swirl each one exactly the same. Okay. So let's see here, my controls. Okay, so my controls are my length of wire. Okay. My temperature in my garage, or temperature of the solutions, because that just depends on whatever's in my garage. I can't exactly temperature control my garage, but the point is they'll all be at the same temperature, so that's the control. Okay, the volume of my silver nitrate, the concentration of silver nitrate, and finally, the amount of swirling. Okay. So those are what things that I'm controlling. All right, so I'm going to show you a couple of the pieces of wire so you can see what I mean by the amount of tarnish on them. So what I did is I cut 1-inch segments, and then from those 1-inch segments, I cut 1/2-inch segments. So you can see one of these is definitely a lot more gunked up than the other one. So let's see if that actually affects how fast copper wire will dissolve. Okay, obviously we're not going to watch the experiment in real time on Zoom because that would take a very long time. So I'm going to set it up and then I will check in on it periodically because a lot of experiments do take time. Sometimes we design experiments that can be done in the course of a single or 2 lab periods, but when we're conducting larger studies, they take a little bit longer to do, which is why I'm making sure that we work on your term project throughout the next 6 weeks versus letting you just wait until the last week, because if you wait until the last week, you will not have time to complete your project. All right, now I'm working with chemicals for my project, so I'm going to go ahead and put on a little bit of what we call PPE, personal protective equipment. Now I'm going to put on lab goggles. I am going to put on gloves. Silver nitrate, when you first pour it out, it doesn't look like it has anything in it. It's just a clear solution. But if you get it on your hands and then you expose your hands to sunlight, anywhere that silver nitrate hit, your hands will turn black. So I'm going to try to prevent my hands from turning black. And let's throw on a lab coat here. Okay, and then to make sure that I'm being safe, I'm going to go ahead and fasten it. I'm not working with anything super dangerous, but we always want to make sure that we are following proper safety protocols when we are dealing with chemicals. All right, so I've labeled my cups 0 through 4. So 0 being the one that I felt had no tarnish on it whatsoever, up to 4, which is the one that I felt was the most tarnished. Let me snap my sleeves here so they don't get in my way. Actually, this one needs to be snapped on the other one. Just a moment here. The snaps allow me to put the coat on easily, but then to make sure that the sleeves aren't so loose that they are going to catch on things. Okay, so I'm going to use a graduated cylinder to pour out exactly 50 mils of my solution for each of my cups. In chemistry, we teach students to read things at eye level. So I'm going to get down. Okay, there's the first one. And as you can see, as I'm pouring it in, it's not blue. Okay, the blue color that you saw in the beaker I showed you a little bit ago is actually coming from the copper that goes into solution. It forms what's called a copper 2 ion, and the copper 2 ion has that characteristic blue color. So there's my second one. Okay. There's my third one. Almost done. There's my fourth one. Okay. And last but not least, there is my fifth one. Okay. So now I'm going to give each one 3 swirls just to get it started. And now I can let them sit. Okay. One thing I need to make sure that I do is keep a data table. Okay, so I'm going to take my gloves off now since that's all set up. Okay, and I'm going to make my data table. Okay, there's my ruler. Okay, and on my data table, I'm going to have my cups. So I have cups 0, 1, 2, 3, and 4. And then I'm going to have time 0. And at time 0, I have 0% of my wire dissolved. Okay, and then I'm going to check these at periodic intervals and estimate the percentage of the wire that's dissolved at each of those periodic intervals. Now, if I were doing a more careful study, I would come up with a way to accurately figure out how much of each wire has dissolved versus just kind of eyeballing a percentage of the wire. And so we can sometimes you might have to adjust things based on the equipment that you have available to you. But one thing that shouldn't be subjective, though, is if one wire is gone completely before any of the other wires is. That is easy to see versus just kind of percentage wise. So mostly I'm just looking to see, all right, which one is going to go first? But I'm still going to check on it periodically and see if I can figure, well, it looks like about half of that's gone or most of it's still there, so on and so forth. All right. So now your job is to start figuring out what sort of experiment you can do. Okay, so think about your life. Think about what you have available to you. Think about some sort of curiosity you have or problem that you want to solve and start coming up with those ideas. Because again, the first part of this assignment, you have to have 3 ideas. Once you have presented your 3 ideas to me, I'll look at them and I will figure out, based on what you've written up, if one of them seems like it just really probably isn't going to work, or if there's one idea that you really, really want to try, that's the one that I'll look at closest and give you feedback on. Once you've been given that feedback, then you'll take that and write up a full proposal of the project that you want to do. Once your proposal's been approved, then you can go ahead and get started on your project. We will have at least one discussion board check-in as you're working on your project so that you can talk about your projects with your classmates and just make sure that you're actually working on them. And again, not leaving your project until the very last week. All right, so I hope you have fun coming up with your projects. The other times I've taught this class, I've had some really interesting student projects presented. So most of the time, it seems like students enjoy doing this and trying to figure out something, again, in your own life that you're either trying to solve a problem from or that you're just curious about. Sometimes it can be something that you're just looking around like I was doing. I was trying to figure out, all right, what can I demo this semester for my students? And I was digging through some of my supplies and I went, this wire's got a whole bunch of different tarnish on it. Let's see if that affects something. So it can be an idle curiosity like that, or it can be something that's been bugging you for a long time. So anyway, start thinking about those project ideas, and I hope you have fun with this.